Chapter 6 is about the foundations of business intelligence regarding databases and information management. So the learning objectives for this chapter is for students to describe how the problems of managing data resources in a traditional file environment are solved by a database management system, describe the capabilities and value of a database management system, apply important database design principles, evaluate tools and technologies for accessing information from databases to improve business performance and decision making, assess the role of information policy, data administration, and data quality assurance in the management of a firm's data resources. So on this chapter, we will be describing a hierarchy of data that is used to store information in a database, progressing from the database as the top-level holder of information in a company or in an organization down through the field, which stores information about an entity's attribute. So an effective information system or IS provides users with accurate, timely, and relevant information. Accurate information is free of errors. Information is timely when it is available to decision makers. Decision makers could be our senior managers or operational managers in a company when it is needed. Information is relevant when it is useful and appropriate for the types of work and decisions that require it. You might be surprised to learn that many businesses don't have timely, accurate, or relevant information, and this could be caused by the data in their information system that have been poorly organized and or maintained. That's why data management is so essential. So to understand the problem, we will be studying on how information systems arrange data in computer files and traditional methods of file management. So a computer system organizes data in a hierarchy that starts with bits and bytes, and then progresses to fields, and then records, files, and then its databases. A bit represents the smallest unit of data a computer can handle. A group of bits naman is called byte. It represents a single character. It could be a letter or a number or another symbol. A grouping of characters into a word naman, or a group of words, or a complete number. Number or word could be a person's name or age, is then called a field. And then, a group of related fields such as a student's name, the course taken, the date, and the grade comprises a record. A group of records of the same type is called a file. So for example, there could be a records that could constitute a student course file. A group of related files makes up a database. The student course file could be grouped with files on students' personal histories and financial backgrounds to create a student database. A record describes an entity. So an entity is a person or a place, thing, or event on which we store and maintain information. Each characteristic or quality describing a particular entity is called an attribute naman. So for example, a student ID, course, date, and grade are attributes of the entity course. The specific values that these attributes can have are found in the fields of the record describing the entity, which is the course. So as we can see on the diagram, we have here the data hierarchy. So a computer system organizes data in a hierarchy. Let's start with bits. Ano po? It could be zeros or 1. And then from bits, we'll be having a byte. And then bytes can be grouped to form a field. And then related fields naman creates a record. Then related records can be collected to form a file. And related files can be organized into a database. So we have here a student database. We have there our student ID, the course, the date, and the grade. For the record, we have the student ID, the course, the date, and the grade of each student. The field, course field, is described with ISO 101. The byte can be described in ASCII with 01001001 value, and then we have a bit with a representation of 0. Ano ba? So, started with a bit, and then created a byte, and then related bytes created a field, and then related field created a new record, and then from related records, it created a file, and then created a database. Problems with the traditional file environment. So in most organizations, systems tended to grow independently without a company-wide plan. Accounting, finance, manufacturing, human resources, and sales and marketing all develop their own system and data files. That means na hindi interrelated yung mga data circulating in each company. So in this diagram, it illustrates the traditional approach to information processing. Each application, of course, required its own files and its own computer program to operate. So, for example, the human resources functional area might have a personal master file, a payroll file, a medical insurance file, a pension file, a mailing list file, and so forth, until tens, perhaps hundreds of files and programs existed in their computer system. In the company as a whole, this process led to multiple master files created, maintained and operated by separate divisions or departments. As this process goes on for 5 to 10 years, the organization is saddled with hundreds of programs and applications that are very difficult to maintain and to manage. The resulting problems are, first, data redundancy and inconsistency. So as we define, database serves many applications by centralizing data and controlling the redundant data. So DBMS, or the Database Management System naman, on the other hand, includes interfaces between applications and physical data files. It separates the logical and the physical views of data and solves problems of the traditional file system, including the control and redundancy. It eliminates inconsistency with data, uncouples programs and data, and enables organization to centrally manage data and data security. So from this diagram, we will be able to see the human resources database with multiple views. So a single human resources database provides many different views of data depending on the information requirements of the user. Illustrated here are two possible views, one of interest to a benefit specialist and one of interest to a member of the company's payroll department. So as you can see, we have here the database for human resource, including the employee ID, the name, the SSN, the position of the employee, the date hired, the gross pay, net pay, the life insurance benefit of each employee, the pension benefit, and its health care. But due to data redundancy, so we could have multiple data, including the name, the healthcare benefits, and as well as for the payroll. We have here our relational DBMS or database management system. The contemporary DBMS use different database models to keep track of entities, attributes, and relationships. The most popular type of DBMS today for PCs as well as for larger computers and mainframes is the relational DBMS. Relational databases represent data as two-dimensional tables which we call relations. Tables may be referred to as files. Each table contains data on an entity and its attributes. Microsoft Access is a relational DBMS for desktop systems, whereas the DB2, the Oracle database, and Microsoft SQL Server are relational DBMS for larger or large mainframe and mid-range computers. MySQL is a popular open source DBMS. So again, when we say open source, it is widely available over the internet and it is for free. And Oracle Database Lite is a DBMS for mobile computing devices naman. So moving on this figure of our relational database tables, we will be able to see how we can organize data about suppliers and other parts. The database has a separate table for the entity supplier and a table for the entity part. Each table consists of a grid of columns and rows of data. Each individual element of data for each entity is stored as a separate field, and each field represents an attribute for that entity. Fields in a relational database are also called columns. For the entity supplier, the supplier identification number, the name, the street, the city, the state, and the zip code are stored as separate fields within the supplier table, and each field represents an attribute for the entity supplier. The actual information about a single supplier that resides in a table is called a row. Rows are commonly referred to as records, or in very technical terms, it could be tuples. Data for the entity part have their own separate table then. The field for the supplier number in the supplier table uniquely identifies each record so that the record can be retrieved, updated, and sorted. It is called a key field. Each table in a relational database has one field that is designated as its primary key. This key field is the unique identifier for all the information in any row of the table, and this primary key cannot be duplicated. The supplier number in the table is the primary key for the supplier table, and the part number is the primary key for the part table. So, the supplier number appears in both the supplier and part tables. In the supplier table, supplier number is the primary key. When the field supplier number appears in the part table, it is then called as a foreign key, and is essentially a lookup field to look up data about the supplier of a specific part. So this one represents our part table that we have discussed earlier. The operations of a relational database management system. So relational databases or database tables can be combined easily to deliver data required by users, provided that any two tables share a common data element. Suppose we wanted to find in the database the names of suppliers who could provide us with part number 137 or part number 150, for example, from the table. We would need information from two tables, the supplier table and the part table. So, these two files have shared data element, which is our supplier number. In a relational database, there are three basic operations that are used to develop useful sets of data. We have the select, the join, and project. The select operation creates a subset consisting of all records in the file that meet stated criteria. Select creates, in other words, a subset of rows that meet certain criteria. In our example, we want to select records from rows from the part table where the part number is equal to 137 or 150. The join operation combines relational tables to provide the user with more information than is available in individual tables. In our example, we want to join now the shortened part table, which would only include parts 137 or 150. And the supplier table into a single new table. And then lastly, the project operation creates a subset consisting of columns in a table, permitting the users to create new tables that contain only the information required. From our example, we want to extract only from the new table the following columns, which are the part number, yung part number natin, which is 137 and 150, the part name would be door latch and door molding, and then the supplier number and the supplier name that could provide that specific parts in the company. Moving on, the non-relational databases and databases in the cloud. So for over 30 years, relational databases technology have been the gold standard. Cloud computing and precedently, data volumes, massive workloads for web services, and the need to store new types of data require database alternatives to the traditional relational model of organizing data in the form of tables, columns, and rows. companies are turning to NoSQL or the non-relational database technologies for this purpose. For they see that it is more flexible in terms of data model and are designed for managing large data sets across many distributed machines for easily scaling up or down. The object-oriented DBMS or OODBMS can store data naman and procedures as objects. Objects can be graphics, multimedia, Java applets, which is relatively slow compared with relational DBMS for processing large numbers of transaction. It also includes hybrid object object relational DBMS, providing capabilities of both OODBMS and relational DBMS. Here are some capabilities of data management systems. Data definition capability, which specifies structures of database content used to create tables and define characteristics of the field. Next is the data dictionary. So data dictionary is about automated or manual file storing definitions of data elements and their characteristics. Data manipulation language is used to add, change, delete, and retrieve data from databases. So many DBMS have report generation capabilities for creating polished reports through the use, for example, of crystal reports. So we have here a Microsoft Access Data Dictionary features. So it has rudimentary data dictionary capability that displays information about the size, the format, and other characteristics of each field in a database. Displayed here is the information maintained in our supplier table a while ago. So we have here our supplier number, the name, the street, city, state, and our zip code. So the small key icon represents, wait for a while. So this one represents that it is our key field. Ano po? Or our primary key. So primary key for our supplier table is our supplier name. So as you can see here, we have our data type and the description. We can also set other characteristics of each data, including the size, the format, and other things that could describe or could help us manage the data more efficiently. So this figure illustrate the SQL statement for a query to select suppliers for parts 137 or 150, which is our example a while ago. So they produce a list with same result as we have on our last figure. So we select part with part number, with part name, the supplier number, and the supplier name from the tables part and supplier were. So in this statement, we will be stating the condition or the criteria that we need. Where part supplier number is equal to the supplier number and part number 137 or part number 150. So in this figure, we have here our query which would be constructed using the access query building tools. It shows the table fields and the selection criteria used for the query. So as you can see, we have here our criteria on the bottom part, the 137 or 150, which will be coming from our table part with a field part number. And then we have here our fields part name, the supplier number, and supplier name, which will be reflected on our resulting table or our project. In designing databases, there should be a conceptual or logical design, which would include abstract model from business perspective. So again, we'll be going back on how you understand the different processes within an organization. That is why it is important that you fully understand the process within an organization before creating any conceptual design. The physical design includes how the database is arranged on direct access storage device or devices. The design process identifies relationships among data elements, redundant database elements. So, most efficient way to group data elements to meet business requirement needs of application programs. And the next one, we have our normalization. So, the conceptual database design describes how the data elements in the database are to be grouped. The design process identifies relationships among data elements and the most efficient way of grouping data elements together to meet business information requirements. The process of creating small, stable, yet flexible and adaptive data structures from complex groups of data is called normalization. In the particular business model here in our succeeding figures, so an order can have more than one part, but each part is provided by only one supplier. If we build a relation called order with all the fields included here, we would have to repeat the name and address of the supplier for every part on the order. Even though the order is for parts from a supplier or a single supplier, this relationship contains what are called repeating data groups because there can be many parts on a single order to a given supplier. So a more efficient way to arrange the data is to break down order into smaller relations, each of which describes a single entity. If we go step by step and normalize the relation order, we emerge with the relations. Ano po? Which we can see on this figure. So you can find out about normalization from this table. So an normalized relation contains repeating groups. So there are repeating groups of data on an unnormalized orders or data. For example, there can be many parts and suppliers for each order. There's only one-to-one corresponds between order number and our order date. So as you can see, we have here our part table, our supplier table with our primary key, the part number, primary key for our supplier, It's the supplier number. For our order, we have our order number as our primary key. And in line item, we have our keys such as the order number and the part number. The ERD or the entity relationship diagram is used by database designers to document the data model. It also illustrates relationship between different entities. The distributing databases, storing database in more than one place, is used by partitioning or partition and replication. So, partition means separate locations store different parts of database. And replicated naman entails central database duplicated in entirety at different locations. So, on this diagram, we can see an example of an ERD. So, this diagram illustrates the relationship between the entities, supplier, the part, the line item, and the order. The boxes represents entities. So, the lines connecting the boxes naman represents the relationship between each entity. A line connecting two entities that ends in two short marks designates a one-to-one relationship. So, kapag may two lines, so that indicates, or two short marks, so that indicates one-to-one relationship. A line connecting naman two entities that ends with a cross foot topped by a short mark indicates one-to-many relationship. So, on our figure, this shows that one order can contain many line items. So, that means that a part can be ordered many times and appear many times as a line item in a single order. So, each part can have only one supplier, but many parts can be provided by the same supplier. It can be emphasized enough if the business doesn't get its data model right. So the system won't be able to serve the business well. The company's systems will not be as effective as they could be because they'll have to work with data that may be inaccurate, incomplete, or difficult to retrieve. So understanding the organization's data and how they should be represented in a database is perhaps the most important lesson you can learn from our lessons. So, very large databases and systems require special capabilities and tools that will be utilized to analyze large quantities of data and to access data from multiple systems. So, there are three key techniques that we can apply or we can use. First, we have our data warehousing, the data mining, and tools for accessing internal databases through the web. So, the traditional tool for analyzing corporate data for the past 2 decades has been the data warehouse. A data warehouse is a database that stores current and historical data of potential interest to decision makers throughout the company. So the data originate in many core operational transaction systems such as system for sales, the customer accounts, and manufacturing, and may include data from website transaction. So, another one is our data mart. So, companies often build enterprise-wide data warehouses, where a central data warehouse serves the entire organization, or they create smaller decentralized warehouses called data marts. So, a data mart is a subset of a data warehouse in which a summarized or highly focused portion of the organization's data is placed in a separate database for a specific population of users. So, for example, a company might develop marketing and sales data marts to deal with customer information. So, from this diagram, we can see the components of a data warehouse. We have here our internal data sources, which includes operational data, the customer data, the manufacturing data, and our historical data. And another part is the external data sources, which includes the external data. So, the data warehouse extracts current and historical data from multiple operational systems inside the organization. Then, these data are combined with data from external sources and reorganized into a central database designed for management, reporting, and analysis, which will then be used for decision making. The information directory provides users with information about the data available in the warehouse. Moving on with business intelligence. So, there are tools for consolidating, analyzing, and providing access to vast amounts of data to help users make better business decisions. So, for example, is the Harris Entertainment analyzes customer to develop gambling profiles and identify most profitable customers. The principal tools include the software for database query and reporting, the OLAP or online analytical processing, and as well as the data mining. So, suppose your company sells 4 different products: the nuts, the bolts, washers, and screws. So, in the East, West, and Central regions, if you wanted to ask a fairly straightforward question, such as how many washers sold during the past quarter, you could easily find the answer by querying your sales database. But what if you wanted to know how many washers sold in each of your sales region and compare actual results with projected sales? So, to obtain that answer, you would need an online analytical processing or OLAP. So, this supports multidimensional data analysis, enabling users to view the same data in different ways using multiple dimensions. So, each aspect of information, the product, the pricing, the cost, and especially the region or time period represents the different dimension. So, a product manager could use a multidimensional data analysis tool to learn how many washers were sold in the East in June, for example, how that compares with the previous month and the previous June, and how it compares with the sales forecast. So, it enables users to obtain online answers to ad hoc questions such as this in a fairly rapid amount of time, even when the data are stored in very large databases. So, on this figure, we'll be able to see a multidimensional data model or model that could be created to represent products, regions, actual sales, and projected sales. So a matrix of actual sales can be stacked on top of a matrix of projected sales to form a cube with 6 faces. If you rotate the cube 90 degrees one way, the face showing will be product versus actual and projected sales. If you rotate the cube 90 degrees again, you will see region versus actual and projected sales. If you rotate naman 180 degrees from the original view, so you will see projected sales and product versus region. So cubes can be nested within cubes to build complex views of data. So a company would use either a specialized multidimensional database or a tool that creates multi-dimensional views of data in relational databases. Let's move on with data mining. So traditional database queries answer such questions as how many units of product number 403, for example, were shipped in February 2020. OLAP or multidimensional analysis supports much more complex requests for information such as compare sales of product 403 relative to plan by quarter and sales region for the past 2 years. With OLAP and query-oriented data analysis, users need to have a good idea about the information for which they are looking. So with data mining, it is described as more discovery driven. It provides insights into corporate data that cannot be obtained with OLAP by obtaining hidden patterns and relationships in large databases and inferring rules from them to predict future behavior. So the patterns and rules are used to guide decision making again and forecast in the organization. So there are different types of information obtainable from data mining. We have associations, which are occurrences linked to a single event. In sequences, events are linked over time. So we might find, for example, that if a house is purchased, a new refrigerator will be purchased within 2 weeks, 65% of the time, and an oven will be bought within 1 month of the home purchase, 45% of the time. Then, we also have classification, which recognizes patterns that describes the group to which an item belongs by examining existing items that have been classified and by inferring a set of rules. For example, businesses such as credit card or telephone companies worry about the loss of a steady customer. So it can help discover the characteristic of customers who are likely to leave and can provide a model to help managers predict who those customers are so that the managers can devise special campaigns to retain that customers. Next one, we have clustering. Clustering works in a manner similar to classification when no groups have yet been defined. So data mining tool can discover different groupings within data, such as finding affinity groups for bank cards or partitioning a database into groups of customers based on demographics and types of personal investments. And then last one, we have forecasting. So it uses predictions in a different way. It uses a series of existing values to forecast what other values will be For example, forecasting might find patterns in data to help managers estimate the future value of continuous variables such as sales figures. The next one, we have our predictive analysis. So, predictive analysis uses data mining techniques that we have mentioned, the historical data, and assumptions about future conditions to predict outcomes of events. So, example of which are probability that a customer will respond to an offer. We also have our text mining. So, text mining tools are now available to help businesses analyze data. So, these tools are able to extract key elements from unstructured big data sets, discover patterns and relationships, and summarize that information. On the other hand, we also have our web mining. So, the discovery and analysis of useful patterns and information from the World Wide Web is what we call our web mining. So, businesses might turn to web mining to help them understand the customer behavior, evaluate the effectiveness of a particular website or quantify the success of a marketing campaign. So, under our web mining, we have the web content mining, which entails knowledge extracted from the content of a web page, the web structure mining, and web usage mining, wherein user interaction data recorded by a web server. The databases and the web. So, have you ever tried to use the web to place an order or view a product catalog? So, most likely during the pandemic, diba, we were able to exercise these actions. So, if so, you were probably using a website linked to an internal corporate database. Many companies now use the web to make some of the information in their internal database available to customers and business partners. So, suppose, for example, a customer with a web browser wants to search an online retailer's database for pricing information, which we can see on this diagram. So, from this figure, it illustrates how the customer might access the retailer's internal database over the web. The user accesses the retailer's website over the internet using web browser software on his or her client PC. The user's web browser software requests data from the organization's database using HTML commands to communicate with the web server. Because many back-end databases cannot interpret commands written in HTML, the web server passes this request for data to software that translates HTML commands into an SQL, so the commands can be processed by the DBMS working with the database. In a client-server environment, the DBMS resides on a dedicated computer called a database server. So, the DBMS receives the SQL request and provides the required data. The middleware transfers information from the organization's internal database back to the web server for delivery in the form of a web page to the user. So, this also shows that the middleware working between the web server and the DBMS is an application server running on its own dedicated computer. The application server software handles all application operations, including transaction processing and data access between browser-based computers and a company's back-end business applications or databases. The application server takes requests from the web server, runs the business logic to process transactions based on those requests, and provides connectivity to the organization's back-end systems or databases. So, we could also establish an information policy. So, an information policy specifies the organization's rules for sharing, disseminating, acquiring, standardizing, classifying, and inventorying information. So, this policy lays out specific procedures and accountabilities, identifying which users and organizational units can share information, where information can be distributed, and who is responsible for updating and maintaining the information. So, for example, a typical information policy would specify that only selected members of the payroll and HR department would have the right to change and view sensitive employee data, such as employee salary or social security number, and that these departments are responsible for making sure that such employee data are accurate and correct. On the other hand, we have our data administration, which is responsible for the specific policies and procedures through which data can be managed as an organizational resource. And we also have our data governance, which is used to describe many of these activities. It has been promoted by IBM, which deals with the policies and processes for managing the availability, usability, and integrity and security of the data employed in an enterprise. And then lastly, we have our data administration. So, a large organization will also have a database design and management group within the corporate information system division that is responsible for defining and organizing the structure and content of a database and maintaining the database. In close cooperation with users, the design group establishes the physical database, the logical relations among elements, and the access rules and security procedures. So the functions it performs in this manner is called database administration. So a well-designed database and information policy will go a long way toward ensuring that the business has the information it needs. However, additional steps must be taken to ensure that the data in organizational databases are accurate and remain reliable. Before, new databases in place need to identify the correct faulty data and establish better routines for editing data once a database is in operation. The data quality audit is a structured survey of the accuracy and level of completeness of the data in an information system. Data quality audits can be performed by surveying entire data files, surveying samples from data files, or surveying end users for their perceptions of data quality. On the other hand, data cleansing is also known as data scrubbing. Consists of activities for detecting and correcting data in a database that are incorrect, incomplete, improperly formatted, or redundant. And that ends our discussion for Chapter 6.